Okay, these are the spring constants K, 2K, and this is K by 2. Length of this is L by 2. This is L and L by 2. There's a block. There's a block, so they will expand here. So there's a block A, there's a block B. So both are having quotient of linear expansion is alpha. So I'll rise the temperature by an amount, delta theta. You have to calculate, find the energy stored in the spring. So these are the metal blocks. And insulated springs, thermally insulated springs. So I'll rise the temperature. Both the metal blocks will expand. So let the temperature of the system rise it by delta T. We have to calculate how much of elastic potential is stored in the springs. Find the elastic potential energy when the temperature of blocks are raised by amount delta T. Okay, now look at the condition I made like this. So what was the length of the block A and block B? L and L by 2, initial length. What do you expect? Both the blocks will expand, no? Both the blocks will expand. So let me take the diagram, the same diagram, slight modification, I'll do it. So shall we put now, this is like L plus delta LA. And what about this? L by 2 plus delta L by, length is L by 2. So it got elongated. Now what can be the spring forces? What will happen to all springs? Which spring will elongate? Which spring will undergo compression? All the springs will undergo compression. The compression of this spring, let it be x1. The compression of this spring, let it be same x2. So we don't know that value. I think I wrote something of like this. X4, I'll write it so that it'll be easy for me. So, sir, why you are writing this one? So actually, this block will expand, no? Will expand like this. So shall we just indicate some for our convenient? There'll be expansion x1. So here what happened? This will expand x2. This will expand. Means here the spring will undergo compression x3. This spring will undergo compression x4. So what are that x1? X1 is the compression of the left spring. What is the compression of this spring? So let me write, I think kx, I'll write it. So this will be, because if I write symbol, kx. What is the compression of this spring? X2 plus x3, because this edge will move, this edge will also move. So x2 plus x3 is the compression of this spring. What is the compression of this spring? Is x4. Okay, now look at this. What will happen to this distance? There's a wall, no, rigid wall. So the distance should not change. So therefore, the sum of elongation of these two blocks should be equal to what? The sum of compression of springs. Able to understand? Now you would ask questions. Why you are taking different this one? Because see, this will expand, this will expand. No, why the expansion of these two blocks should be same? You look at the length, same material, but lengths are different. So what do you expect? The elongations should be different here. So what is the compression in the spring? The expansion of blocks should be equal to the increase in length of the block should be equal to decrease in length of the spring, sum of decrease in length of the spring. So therefore, we'll write like this here. Increase in length of blocks, sum of increase in length of blocks must be equal to sum of decrease in length of spring. What is the increase in length of the blocks? So delta L, block A will expand. Similarly, the block B will expand. Go back to the basics. Change in length depends on what? Change in length depends on the initial length of the object also, no? Look at the length of block B, L by 2. Length of the block is L. So as you change this, the elongation also should be different. Okay. Okay, now what is the sum of decrease in length of the springs? X1 is the decrease in length of left spring. What is the decrease in length of the middle spring? X2 plus X3. This is the concept where students will miss. I'm putting bracket. Are you able to understand this one? This is for what? Middle spring. This block will expand, this block will expand. So the spring will undergo compression. So the displacement of either ends will be different, x2 plus x3. That is the compression. X1 is the compression of the spring. X4 is the compression of the spring. So what is delta? So many unknowns are there, no? We should find out all these things. Okay, what is delta LA? We'll write it first. What is delta LA? L alpha delta theta. What is delta LB? L by 2 alpha delta theta. X1, let me keep as it is this equation. So this will be 3L by 2 delta theta. Okay, there's the equation 1, you keep it. What is the state of this? They are in equilibrium, no? Blocks are at rest. If the blocks are at rest, what the net force on that should be 0. So 2K x1 should be equal to 2kx. Sorry, kx1. Kx1 should be equal to 2kx. So therefore, this will be x1 equal to 2x. What is x? X should be x2 plus x3. I'll write it here. Now, what is X? Compression in middle spring. I will write all the terms. What is the meaning of that? Everything. Some of you are unable to understand anything here. Now, what is the X? X is the compression middle string. So, what is X1? Compression in left spring. X4, compression in right spring. You can't write x1 equal to x2. It should be derived. You can't think whatever you want. X1 equal to x2 this one. So further this will be x1 equal to 2 into. How lollipop will be equal to chocolate? Same thing here. Why x1 is not equal to x2? Both the ends will have different displacement. Similarly for block B, this is for block A, for block B. 2kx should be equal to k by 2 x4. So this will be, so this will be 4k for 4x is equal to x4. So what is x equal to? x2 plus x3. So what is the equation what we have? 4x2. Let me expand it. 4x2 plus 4x3 equal to x4. There's equation 1, equation 2, equation 3. I'll come. Somebody like Yochan and Ambali, both of you, Vardhan, both of you asked, sir, what to do with x1, x2? I want everyone to think. Huh? So let's see that. How many unknowns are there? There's a one equation. We have this much, no? How many unknowns are there? x1, x2, x3, and x4. We need one more equation. Anybody? Yochan and Vardhan, both of you asked something like x1 equal to x2, x1 plus x2 equal to delta LA. Some of you are just put in chat box. Okay, now, okay, that one. Number of unknowns are more, no? I need one more equation. Tell me whose help I should take here now. Anybody wants to reply back? Yochan, yeah, you asked something, sir. Why can't we write x1 equal to x2?
Yes, sir.
Tell me like why you want to write x1 equal to x2?
Sir, we can take equivalence on either sides, no, sir.
How come? How you can say that? Yashovardhan? Yeah.
Yes.
Tell me what is, you wrote something x1 plus x2 should be delta LA. Any reason for that?
Sir, increase in length of blockage should be the compression in
Right.
2K1 and K.
Yeah, that one. So it should be like a delta LA should be x1 plus x2. Am I right?
Yes, sir.
Then delta LB?
X3 plus X4.
But already we wrote one more equation here. What about this? Can we, is it justify this also? Same thing, no? This is actually this equation only, instead of writing this one, individually you can write delta LA equal to x1 plus x2, delta LB is equal to x3 plus x4. So the equation one, what pen will split up into two parts actually. So instead of this, what pen you could have written delta LA equal to x1 plus x2. And what is delta LA? L by 2, L alpha delta theta x1 plus x2. L by 2 alpha delta theta equal to x3 plus x4. Then 4 equations, 4 unknown. I think we can solve. Agree this. So shall we? So if you want, okay, keep it, or you can write here like for block A. So few more equations will write same thing. Delta LA should be equal to what, like x1 plus x2. So delta LA is equal to L alpha delta theta. Similarly, delta LB is equal to x3 plus x4. So there's equation 4. There's equation 5. Solving what happened, we'll get 1, 2, 3, 4, 5, or 1 you can avoid. Solving 2, 3, 4, 5 will get the required answer. Solve for any one. If you get x1, you may get it here. So you can do one thing. First, you break x4 in terms of x3 and x2, you write it here. So you'll get equation x3 and x2 in terms of this one. Then x3 in terms of x2, you can substitute here. Then we have relation between x1 and x2. Then x2 you can replace in terms of that one. Then solving will get the required answer. Can you solve this? Solve 1, 2, 3, 4. Little bit lengthy. Equation 1, okay, that one, same thing. 4, 5 you split up, no, it'll be easier. Eliminate, put 4 in 1, will get expression for x2, that one and all. So you should eliminate, you should get x3 in terms of x2. So therefore what you should do now, so put x4 here, that one, then you'll get x3 in terms of x2. Then again you have to use equation 2, then everything what happened will get expression for x2 here. Okay, I think some of you are asking. I'll solve it. Please do solve. All right. I'll come to this later on. Okay, let's get into calculation part. Okay, all of you are able to see this? This 1, 2, 3, 4, 5. 1 may not be needed. Just I wrote it so that you'll get a better picture. Okay, now let's solve that one by one. So I'll put 4 in 1. So first put 3 in 5. Let me put 3 in 5. L by 2 alpha delta theta x3. x4 will be 4x2 plus 4x3. So L by 2 alpha delta theta equal to 5x3 plus 4x2. So let me call this is equation 6. 6 signed 4 in 2. Yeah, put 6 and 4 into that one. So this will be, let me eliminate x1. So L by 2, L alpha delta theta minus x2 equal to 2x2. 2x3, I have to eliminate, no? So therefore this will be L by 2 alpha delta theta minus 4x2. 2 by 5. So we have only x2. Solve this. This will be a check calculation, equal to x2 plus 2x2 minus 8x2 by 5. So 2 get cancelled. So 5, 4, this will be 8, 5, 5 3 are 15, 15 minus 8, 7, 7x2 by 5. Solving this, x2 will be check one's calculation. Somebody's telling x3 will be negative something.
Yes, sir. X-ray will be negative. Sir.
Yes, so X3 will be negative, sir.
It will be negative.
X3 will be negative. Huh? Okay, let it be, no problem. Yeah. So we have to take the, then what is x? X will be the compression, the spring will be x2 minus x3 will come like that. Okay, x2 I got it. Anybody value? All the values?
Sir, X1 is 3 by 7, sir. 3 by 7 alpha delta alpha.
X2 value.
4 by 7 L alpha.
4 by 7. X3.
Minus 5 by 14. Sir.
Okay, no problem. Yeah. X4.
6 by 7.
Okay, let it be this one. So what is the compression in the, I think spring 1 will undergo compression. What about spring 2? X2 plus X3 is what we took compression. Now substitute X3 negative value and solve it. That's all. No, let's not bother that one. The sign will tell us in what direction actually it will undergo displacement. Then similarly the X4. So now what is the total elastic potential of the spring will be? Total energy of the spring will be UV should be equal to half K x1 square half 2K x2 plus x3. Substitute which sign? No problem. What is the other spring? K by 2, no? Okay. Little bit lengthy, but good concept. Huh? Okay, I think I have everything. So you do calculation later on. Huh? I think it took more time. Let me, okay, there's a small idea based. Let me take this one here. No, already I just discussed